But we're going to move on to parabolas. I will. I will be lonely today.
You're telling me there are no calc?
No calc kids ever come. And it drives me crazy. Because they get to leave.
But are half of them failing it?
No, I wouldn't say half. Parabolas.
Everyone I know who's taking calc hates it.
I believe it. Okay, so I just published the Canvas page for today. It says cycle 22 e-learning for 317 parabolas in Vertex form. So go ahead and I usually do. The problem with this is my cycles are flipped right now, like between my gold and black day. Like I'm doing this lesson before the black day. So that's why it wasn't published. But it's almost always published for you guys.
Why don't you just go down to your wife's room and head out?
Yeah,
Because I like sitting in here. Like I normally have people in here.
You have enough of her at home, so
I'm recording this lesson. So I love my wife. Okay, so today is all about parabolas. That's the whole lesson today. You guys are actually getting half of parabola info than in most years, every other year. All we're going to be doing are parabolas that open upward or open downward in this chapter and in the semester. There are parabolas that can be sideways that we typically get into, but we're not going to get into those things. I might like briefly mention how that might happen, but I'm not going to get into a lot of the stuff about it. Okay. So we have a couple tasks today. Task number 1 is something that we took out of first semester this year. It's a skill about taking a parabola equation. First of all, what types of equations, Mr. Mundy, what types of equations form parabolas in general? Like if you get this type of equation, you know 100% it's going to be a parabola.
Like isn't it one of the variables is square?
Yeah, yeah. So if I had some equation, you don't need to write this. Sure. So if I had a quadratic equation, quadratic equations, when one of them is squared and the other one isn't, will always be a parabola. Notice I say one of them isn't, because in the circles, both are squared. That forms a circle. So parabola is just one of them is squared. Anytime you have y equals and the x is squared, that's going to be an up or down parabola. What determines if it opens up or down? If it's what? If it's positive or negative. If the x squared is positive or negative. If x squared is positive, it looks like that. If x squared is negative, then it's upside down, looks like that. We aren't, like I said, going to get into sideways parabolas, but you would get a sideways parabola if it was like x equals y squared. That's when you would get sideways parabolas, when the other variable is squared. We're not going to get into that, but that's how you would get that before. So we have a couple tasks today. Task number 1 is to take a quadratic equation that looks something like this, and we are going to make this look like this. We are going to take that quadratic that we know and love, and we can look at that and know it's a quadratic, and we are going to turn that into what is called a vertex form of a parabola. So that's going to be big concept idea number 1 is how do we go from this form to vertex form? Because we get a whole lot of information about the parabola when we're in this form instead. And in that process, we do completing the square. Okay, so if you understood that when you were doing the circle stuff, this is probably not going to be too bad. Okay, so that's task number 1. And in fact, I want to start with that on this problem right here. Okay, I want you guys to go to this example, and I want to show you how to turn this into vertex form. This is big idea number 1 of the day. Okay, I would probably, because this was taken out of first semester, in previous years, this goes pretty smoothly because we had already done this first semester. Students typically need a brief reminder, but it goes pretty well. You guys, since you have not done this before, you might want to make a little like thing off to the side about the steps we take to do this. Okay, so here are the steps that we're going to take to put this into what is called vertex form. Here's our process. Step number one, we are going to take this constant right here that they give us, and we are going to move it over to the other side of the equal sign. So we take that 5 and we move it over. So I write that down as step number one, move the constant over. Step number 2, notice that there's a number in front of the parentheses right here in the form we're trying to get it into. So step number 2, we're actually going to factor this a term out from the right side. We're going to factor this 1/8 out of the right side. Notice I don't say we're taking out the GCF. I'm not doing anything with the x's. I'm going to factor out 1/8 from both of these terms right here. So I'm factoring the a value out. Now here's where we need to be careful when we do that. So I'm going to have x squared minus, what'd you say? 8x. How'd you know it was 8x? It is.
Yeah, 1/8 for 1, you have to multiply by 8.
So you're thinking of like reverse engineering it going backwards. Yeah, spot on. So Riker said 8x. He's 100% correct for 2 different reasons. Reason number 1, when you factor something out, you are dividing. 1 divided by 1/8 is 8. I'll say that again. You have 1 in front of x. You're dividing by 1/8. 1 divided by 1/8 is like 1 times 8, so 8. So that's reason number 1, it's 8. And then also, like Riker said, if you would distribute the 1/8 back in, you have to get back to where you started. Like if I would distribute the 1/8, I need to get back to here. That's why there has to be an 8. 1/8 times 8 gets me back to the 1 in front. Now, just like with the circles, the next step is we need to create that C value right here in the parentheses through completing the square. We're trying to get to that quantity squared right here. So I need to take half of 8 and square it, half of the B value and square it, just like with the circles. So half of 8 squared is 4 squared, so 16. So we're adding 16. So what do I have to do to the other side? Not add 16, suckers. What did we really add to the right side? We didn't really add 16. We added 2. So don't get tricked by this. We didn't really add 16 here. We added 2 because we really added 1/8 of 16. To figure out what you need to do to the left side, you need to multiply 1/8 and that number together, that a value and that number together. So we didn't really add 16. Imagine we distributed the 1/8 into these parentheses. We would really have plus 2 on the end. We really added 2. So we have to add 2 to the left side. Okay. On the left side, I'm going to combine -5 and 2. So y minus 3. And on the right side, the whole reason we create that C value, just like with the circles, is so now we can factor that parentheses and get it to be that quantity squared. That was the whole goal. So now I'm going to factor the parentheses here. But it's just going to be x and then half of your B value squared. I just factored. I found 2 numbers that multiply to 16 and add up to -8. The last step, take that -3 that's on the left and add it over to the right. This process definitely takes practice. The first 2 on your assignment tonight are you guys doing this process. I'll probably have you try this one more time at the end of the lesson. This is big idea number 1 today. And like I said, in previous years, this skill would already have been known coming into the lesson. Like we would have already done this a bunch towards the end of first semester. We didn't this year. Are there any questions about what I did there? So now notice that we have it in vertex form. And I'll explain why that's important here in a second. Is there any questions on any of these steps on what I did? Each step alone is easy, but it's remembering every step to do that's the hard part. No questions? Okay. The reason this is beneficial is this. This is called vertex form right here, because once we have our quadratic or our equation in this form, I can immediately look at it and know what the vertex is. The vertex is h comma k. Just like the center of a circle is h comma k, the vertex of this parabola is h comma k. Now here's where you need to be careful. Notice the signs of h and k in this formula. H is always the opposite of that number in the parentheses, just like with the circles. K is the actual number with the sign staying the same. It's a plus k. So in this formula, I know the vertex is at +4, +3. +4, +3. That's really important. That's the most important part of the parabola is the vertex. And we can easily see the vertex from vertex form. Okay. We have a lot more to talk about. All right. A lot more. So we're going to go back to the front of the notes. So parabolas that you know and love have certain components to them, things you have not been talked about before. And that's what's going to come in today. So every parabola, I'm going to kind of write some things just on this very first one. We're not going to jot stuff all over this page, just on this first one. Okay. So every vertex has, what did I say? Every vertex? Every parabola has a vertex. So that's nothing new. We know that. That's at h comma k. There's nothing new there. However, there is a point that every single parabola in the world has that's kind of like the power point of the parabola. It harnesses all the energy of the parabola. And that point is called the focus point. This point right here, I'm explaining it a little bit more. That point right there in the parabola is called the focus. It's kind of like your eyeball has like a focal point inside of it. You know, I always talk about, anybody know how car headlights work? Huh? Yeah, but how are they really bright? Like, how do car headlights shine so much light, or like flashlights? So light bulbs, but the light bulb doesn't just like shine everything forward. What creates the light being projected forward? The headlight has a parabolic mirror. There's a mirror behind the headlight. And what engineers figure out is they figure out, where should I put that light bulb? And they put it at the focus point so that when the light releases from the light bulb and hits the mirrors, it maximizes the amount of light that then shines forward. So they put the light bulb at the focus point. Or another analogy is like a satellite dish. What? Stop. So like a satellite dish, you know how there's a satellite dish and then there's like the receiver inside the satellite, like the ball or whatever? You know what I'm talking about? Engineers put that at the focus point of that parabola. So like all the airwaves or whatever that come into the satellite dish will bounce directly to that focus point. That's what I mean by it's like the power point of the parabola. That's not something you guys have ever really talked about, but that's another component of the parabola. So we're going to talk a little bit about that. One thing that's going to be important, there are going to be a couple formulas that you guys have to keep in mind. The distance from the vertex to the focus point in every single parabola, the distance from the vertex to the focus is 1/4a. A being the number that is like out in front of your parentheses. We'll talk more about that. That's going to be like big formula number one that we need to know. 1/4a is the distance from the vertex to the focus. Every parabola also has an imaginary line behind it, this line right here, called the directrix. The directrix is not as cool as the focus point, but to be honest, the parabola wouldn't exist without the directrix. The way a parabola gets formed in general, by definition, a parabola is all the points that are the same distance away from a focus point and a line called the directrix. So basically, the parabola starts by there's this line and there's a focus point, and every point that's equidistant to those two things creates the parabola. So without the directrix, there is no parabola in general. Every parabola also has a width to it. Now, a parabola has infinitely many widths, right? Like there's a width here, there's a width here, there's a width here, there's a width here, but there's a special width that goes through the focus point. This width right here that goes through the focus point, so this line right here is called the lattice rectum. So this width right here that goes to the focus point, so connecting from one side of the parabola to the other, is called the lattice rectum. That's how we're going to be graphing our parabolas today, is by finding that width. That width is always the absolute value of 1 over a. Or in other words, it's the reciprocal of a. Whatever a is, the reciprocal of it is how wide the parabola is. So that's kind of all the key components, but I'm going to basically tell you guys there are 4 key things you guys have to know. Okay, I'm going to write these 4 key things down. That if you know these 4 things, then that's what I need you to know for today's lesson. Okay, I'm going to break this down, boil this down to 4 things. Okay, so thing number one, the vertex is always halfway between the focus and directrix. The vertex is always halfway between the focus and directrix. Which makes sense because I said every point on the parabola has to be the same distance away from the focus and directrix. So that has to be true about the vertex. So what I mean is this, notice right here on this little graph, this vertex is 2 units away from the focus. So it also has to be 2 units away from the directrix. So it's smack dab in the middle of the focus and directrix. So that's big thing number 1. Thing number 2, the lattice rectum and directrix are parallel. The lattice rectum and directrix are parallel, meaning the width of that parabola and the directrix are parallel. Now for you guys, that's not a huge deal. Since we're only doing up and down parabolas, these are always horizontal. But if we were doing sideways parabolas, well, now those 2 things would be vertical to each other. So, but we're not getting into that stuff. Thing number 3, the lattice rectum length, so the width, is the absolute value of 1 over a. Why is it absolute value? Why does that matter? Yeah, this is standing for a width or a length or a distance. It has to be positive. Like sometimes that a value will be negative in the problem, but we need to make it positive for that length. But in other words, if you want to make a little note, the easier thing to do, it's really just the reciprocal of a. That's the easier way to think about it. And then big thing number 4, which is probably the biggest, is the distance from the vertex to focus. That distance is 1 over 4a. This will pretty much get used in every single problem you do with these parabolas, is using that little formula. So these are the 4 key ideas that we have to know. You're going to use this info in different ways. Like you'll do your homework tonight. They're going to give you different bits of information. Sometimes they'll tell you where the focus and the vertex is. Sometimes they'll tell you where the focus and the directrix is. Sometimes they'll give you the lattice rectum length. Like they're indirectly giving you everything you need, but you need to know how to like problem solve your way through using these 4 things. Okay. Who's knocking on our door? We're just gonna try. Huh? Seriously? Oh my gosh. Oh. Okay. For me, I would stay home. You okay? Yeah.
Can you repeat number 3?
Like in general, what it means.
Yeah.
So the latus rectum stands for the width of the parabola. We'll get practice with it, but the latus rectum stands for the width of the parabola. The way we find that width, like whatever the a value is. So going back to that first example that we already started, because we're going to finish that problem. Oh crap, where'd it go? So that first one that we put into vertex form, you see how the a value is 1/8? The lattice rectum length, that means would be 8. Like the width of it would be 8 units long, going through the focus point. That's what that third thing means. Okay. All right. So we're going to do just a few of these examples, not all of them, because some of these are sideways. We got a few to do. So we're going to finish this first problem. It says graph this parabola. Well, I know what the vertex is already. We put it into vertex form. And so let's mark where the origin is. Kind of hard to see. Doesn't really matter. As long as you have an origin on your paper, it doesn't have to be where mine is. As long as you mark it. So that's my origin right there. So I know the vertex is at 4, 3. So I'm going to plot it, right? 4 up 3. There's my vertex. But I need to find all this other stuff. I need to find the focus point. I need to find the directrix. I need to find the lattice rectum length, and I need to graph it. I want to find all that other information. Okay. The next thing I want to find is the focus point. I want to find where is the focus point. Well, this is where that vertex to focus comes into play. The distance from the vertex to the focus is 1/4a. And I know the a value. The a value in this problem is 1/8. This is where we just have to be able to have a little bit of computation skills. I'm going to plug 1/8 into this a value right here. So it'd be 1/4 times 1/8. What's 4 times 1/8? 1/2. What's 1 divided by 1/2? 2. So that's what this is. This is 1 divided by 1/2, which is 2. Here's what that means. That doesn't mean, that's not what I put for the focus. That means the focus is 2 units away from the vertex. In most years, we need to do a little more thinking. In this year, well, I know the focus either has to be 2 above the vertex or 2 below it. Will it be 2 above or 2 below? Why above?
There's nothing in the problem.
Yeah, which way? Well, first, which way does this parabola open? It's going to open up, right? Like this parabola is going to look like this. Your focus always has to be in the parabola. So that tells you it's going to be 2 units above. In other years, when we do sideways parabolas and these things can open right and left, we need to think a little bit more about where it is. But again, since this parabola is opening up, the focus is 2 units above this vertex. So that would be right here, which is the point, what is that? 4, 5. So the focus is at 4, 5. I need to find the equation of the directrix. So the focus is a point, the vertex is a point, but the directrix is a line. It's going to be a horizontal line. And if the focus is 2 units above the vertex, the directrix is 2 units below the vertex. The focus and directrix are always the same distance away from that vertex. So the directrix is 2 units below, but I'm not going to name this point. It's this horizontal line right here. So that's the line y = 1. The only other thing I have to find, the last thing, then we can graph this thing, is the lattice rectum length, the width of the parabola. What is the width of this parabola? What is the lattice rectum length? 8. It's just the reciprocal of the a value. The reason it's the reciprocal is because it's 1/a, but if you do 1/1/8, that's the reciprocal of 1/8. Like 1 divided by something means the reciprocal of that thing. So it's 8. So here's how I use that info. That means the width of this parabola is 8 units across the focus point. So from the focus, I'm going to go 4 in both directions, left and right, to put points on this parabola. From the focus, I go 4 to the right and 4 to the left, to the left, to the left. And then I can draw my parabola. Hello, parabola. You must live close, bro. That's quick. I wouldn't worry too much about it. I honestly, if it was me, I honestly would have stayed home. All right, so that's kind of everything in a nutshell. We're gonna practice a couple more, but that's all this stuff. Let's do 4. I'll do 4. So 4 gives the focus and gives the directrix. It says write the equation and draw the graph. So anytime a problem gives you info, I would plot it on the coordinate plane. Give yourself a visual of what's going on with this stuff. So again, mark your origin wherever you want it to be. It doesn't matter as long as everything is relative to where you mark your origin. So my focus is at -3, -2. So left 3, down 2. That's my focus. And the directrix is y equals -6. Y equals -6. So 1, 2, 3, 4, 5, 6. Here's the directrix. So how does that help? Yeah.
You can use that inside your vertex.
They're indirectly telling you what the vertex is. The vertex is always smack dab in the middle of those two things. So the vertex, it has to be right here because that point right there is 2 units from both of them. There's my vertex, and I would probably label that off to the side. So that's going to be, let's see, 1, 2, -3, -4. Okay. So at this point, here's what I know. I'm trying to write this equation, meaning I'm trying to write this. I'm trying to write this. Once you know the vertex, you know H and K already. There's really 3 things you need to know. You need to find H, K, and then whatever the A value is. By finding the vertex, we have H and K. So like at this point in time, I know it's y equals A, and then it's X, and the thing inside the parentheses is always the opposite sign. So it's going to be X plus 3 squared. And then the K value is exactly the sign that you see. So -4. So the number in the parentheses flips, the number outside stays the same in terms of the sign. The only thing I don't know is the A value. How can I find the A value? Yeah, the vertex to focus formula, that 1/4A is pretty much going to be used in every single problem. Meaning if you haven't used it, try to figure out how to use it. On the last problem, you knew the A value. So you plugged it in and you found that distance. Well, on this one, I can see the distance. The distance from vertex to focus is 1/4A, but I can actually see what that number is in this problem. It's 2. I know that fraction has to equal 2. So we can use this formula in both directions. Sometimes you use it and you'll know A. Sometimes you'll use it to find A. So now I just have to solve like this is a proportion. Multiply both sides by 4A. And then divide by 8. So A is 1/8. And then I can write my equation. I'll get a lot of students, this happens a ton too. I get a lot of students that will like do everything correctly, but then they won't put the squared there. They'll write it like 1/8 x plus 3 minus 4. Why is that bad? If you don't put the exponent, the 2 there.
Because the exponent's there because like you passing it down there.
That's why it should be there. But why, what is like, what's the big deal if it's not there? Yeah, if it's not there, it's not a parabola at all. In fact, what is it? It'd be a line. Like this would be the equation of a line. So that 2, it's not just a little number, that's creating the entire graph. So make sure you don't overlook that. Oh, my computer's about to die. That wouldn't be good. I'm gonna have you guys try one more problem. But I need to plug my computer in so you guys don't go bye-bye. That'd be bad. Oh, that was rough. That was a rough block 7 yesterday. I was right in the middle of my last calculus lesson. Okay, all I want you to do, we're not gonna graph anything. All I want you guys to do, and I don't care where you do it on these notes, because we're not doing any of the other problems on these notes anyway. But I want you guys to take this equation, y equals negative 3x squared minus 12x minus 2, and I want you guys to put that into vertex form. So the very first thing we did, you don't need to find any info. All I want you to do is take this and put it into vertex form. Try that out. Try to follow that little 5-step process. You can do whatever. I don't know what you mean by that.
Like we wrote down the steps.
Yeah, that's what I want you to do. I want you to turn. Huh?
No, I mean, I didn't want to do it from memory.
Oh, no. Well, if you can do it from memory, that'd be awesome. But I wouldn't anticipate you can. Maybe you can.
When we like take out a value from the A.
Yeah.
Do we can we after like PPCS?
You don't want to take the X out.
I know, but no, I just take a number out.
You can always take a number out. Yeah, always. Now you hope that B value can be divided by that number. If not, you get some really messy fraction stuff, which I could do to you guys, but that's not my intent. I mean, it could happen, but I'm not trying to crush your guys' soul as much as you guys think I hate you. Like I made it a 12, guys. I could have made it a 13, and that would have made the problem a lot harder.
Yeah, I don't think you hate us. I think you just like seeing it fail.
That's what math teachers.
If I really enjoyed seeing you fail, I would have a lot more people fail. Like I could really put the screws to you guys. I could give you no review days, no practice, make problems super hard.
That really wasn't that hard.
No, it's not. I just wanted you guys to practice one more because you guys didn't get that concept first semester.
I got told last year that complete the square was like the hardest thing they did all year.
Really? That's false.
Anna Peck could not complete the square.
That's also probably false. She probably could do it, but she probably just didn't like it.
No, she forgot how to, because I asked her the other day, and she was like, she never did it right. She's learning the stats.
She doesn't like stats.
I all do stats. Everything is stats.
Well, I don't think there's a single person who likes that.
Well, that's really weird. I was gonna say, that's really weird because when I get kids in calculus and I ask them about stats, like a majority of them like it or look back on it. I think that's what it is. I think when you're in it and doing it and it's difficult, you're not enjoying it. But I think once you finish, you look back, at least is what they tell me, and they can appreciate like what they actually learned. And they do really well on the AP test. His results on the AP stats exam are really good.
I was saying, that's probably not.
Well, it's probably tougher.
They're coming in. I walk with them in the hallways, and they'll be like, "Oh, we have a stats quiz today, apparently."
So here's my equation.
Let's go, I did it right.
And if you didn't, it's not a big deal. We just need to figure out where that little hiccup is, because typically if students don't get this right, there's one place that's a hang up, and we need to identify that one place. I'll walk through this and then we'll be done. You guys have an assignment. So I added 2 as step 1. Then I factor out the a value. Notice I just say factor out the a value, not the GCF. When you do that, -12 divided by -3, that becomes +4. So that's why it's a 4x. Now the completing the square begins. That's why I did it in red, because those are kind of the numbers that were magic is happening. So I took half of 4 and squared it. The number one mistake, students making this, the number one mistake is students either forget to add or subtract a number to the left, or they add this number right here that they just created. They'll put +4 on the left, but you didn't add 4 technically. You really subtracted 12. You need to think, if I would distribute this -3 through here, there'd be a -12 on the end of the right side. You really took 12 away. So you have to take 12 away from the left. Really, whatever that a value is times your number, that's what you have to do to the other side. Then factor, then add the 10 over. What would the vertex of this parabola be? Not 2, 10. -2, 10. It's always the opposite and then stays the same. All right. I was going to add another example, but your homework has a lot of different types. I think there's only 6 questions. It's not a lot of questions, but it has like every single one's a little different. So you'll get really good practice. So I'm going to let you guys off at home. You guys have an assignment. Please email me any questions you have. I can see this assignment being a little bit of a challenge. It's a lot of new stuff. So you guys in here, I'm going to give you the next 32 minutes. You guys can work and ask me questions.
Yeah.
All right. Peace out.
AOS, that actually.
Oh yeah, I didn't talk about that.